Hello and welcome to day 7 of our standard template library course. Today marks an exciting milestone. We are diving into our first mini project. The goal is to build a student database using the std::: vector container. By doing this, we will consolidate everything we have learned so far during week 1. You will get a chance to design, implement, and debug a small functional program that mirrors a real world use case. This project is all about applying your skills, working with structs, vectors, input-output operations, and iterators, all in one cohesive system. Let's get started. This project isn't just about coding, it's a structured review of essential STL concepts. First, we will revisit vector operations like pushback, indexing, and iteration. You will also learn how to define and use structs to represent student data. Iterators and range-based loops will come into play when displaying or modifying data. Input and output handling will be key for interactivity. We will also explore sorting using custom comparators, which introduces more advanced vector manipulation. And finally, you will practice organizing your code into modular functions, a crucial step for writing clean, maintainable code. To manage student data, we start by creating a simple struct. This student struct contains three fields: an integer for roll number, a string for the student's name, and a float for marks. Structs allow us to treat related data as a single unit. Once defined, we can create a vector of student objects to store our database. This approach makes our code more scalable and easy to understand, as each element in a vector represents one student with all their associated information. Here's what we will be building. First, we need a way to add new student entries to our database. Then we should be able to display all the students stored in a vector. Next, we will implement a search function to locate a student by their roll number. Once found, we should be able to update their data, such as name or marks. We will also create a delete option to remove a student record from the list. For an extra challenge, you can add functionality to sort students, perhaps by marks in descending order. And finally, we will give users the ability to exit the problem gracefully. To make the program user-friendly, we will build a menu interface. Think of it like a command line dashboard. Inside a while true loop, we display the menu options repeatedly until the user chooses to exit. This interface prompts the user to enter a number corresponding to their desired action: add, view, search, and so on. Then, based on their input, the program will call the relevant function. This modular menu system not only helps users navigate the program, but also keeps your code clean and well structured. Let's break down the first two features: adding and displaying students. For adding, prompt the user to enter a roll number, name, and marks. Store this data in a student struct and then push it into the vector. Displaying students is straightforward. You loop through the vector using a range-based or traditional iterator loop, printing each student's data neatly. These two operations form the backbone of your database and are the perfect place to begin your implementation. Searching is our first use case that involves decision-making logic. You will iterate through the vector looking for a student whose roll number matches the input. The ideal way to do this is with std::: and a lambda function. Once a student is found, we can prompt the user to input new details, maybe a new name or updated marks, and assign them to the appropriate fields. This teaches us how to manipulate existing vector elements and reinforces concepts like conditional logic and lambda usage. Deleting records follows a similar pattern to searching. Use std::: to locate the student, then remove them using the erase function. Make sure to handle edge cases like if the student isn't found. Sorting adds a function, slightly more advanced twist. With std::: sort and a custom comparator lambda, you can sort students based on marks or names. It's a powerful example of how STL and custom logic work together for real life use cases. Here's a here's a sample of how your program will look when executed. The menu options are clearly displayed and the user can select what they want to choose. For example, entering one allows them to add a new student by entering a roll number, name, and marks. A success message confirms the operation. Keeping your interface clean, informative, and friendly goes a long way in improving the user experience. Now that your program works, it's time to test it thoroughly. Try adding multiple students, then viewing the list to ensure data is stored correctly. Test what happens when you try to search or update a non-existent roll number. Delete a student and check whether they were removed successfully. Finally, sort your list and confirm the order is correct. These test cases help us identify bugs and edge cases, ensuring our code is reliable. Here are some practical tips. Use getLine for name input to handle full names with spaces. Don't shy away from using auto and range-based loops to simplify your code. Always break your code into small, single-purpose functions. It makes debugging easier. And make sure to validate all user inputs before using them, especially in the menu. This attention to detail will help you write cleaner, more resilient code. Are you feeling ambitious? Add some more stretch goals. For instance, save and load your student data from a file using file IO. You could also replace the vector with a std::: map for faster lookups by roll number. Implement grading logic based on marks to assign letter grades or GPA, or introduce auto-incremented roll numbers to streamline student entry. These extra features push your C++ skills further and simulate real-world application development. By the end of today, your goal is to have a complete functioning student database using vectors. This project is a strong foundation. It demonstrates your ability to apply STL concepts to real-world coding tasks. You will leave this session having practiced stack design, vector operations, user interaction, and algorithmic thinking. Debug it, polish it, and be proud you have just built your first mini STL project from scratch.